Hello everyone, welcome back to MuleSoft real-time use case series. As part of this, we are going to solve the below use case. The use case is how many ways we can migrate data from one DB to another DB using MuleSoft. Okay. So the source system is Snowflake. Target is MySQL here. So in this lecture, we are going to see the solution 2. So the previous solution is using foreach and pagination concept, how we are going to migrate data from one DB to another DB. Okay. So when this will work? If you want to process one by one, and if we have less records, I mean 1000 or 2000 or below 10,000, then this will be fine. But solution 2, what is the solution 2? Using parallel for each. Okay, using parallel for each and pagination, how it is going to work, we are going to see. So anyway, we have created one flow for the solution 1. So the same flow I'm going to reuse it here. Okay, the same flow I'm going to reuse it, or else let me quickly create flow. Okay, let me copy paste. So if you observe here, what is the resource path we have given? Okay, data migration use case 1. So here I'm going to keep it as data migration. Instead of use case 1, solution 2 I'll keep. Okay, solution 2. Quickly copy paste. So how to do copy paste? Control C, Control V. Okay, select these connectors. Okay, see what are the connectors. If it is required, okay, let me stop the flows. It is running now. So in this use case, what is required first? The source system. So what is the source system here? Snowflake. Now, what is the target system here? Target system is MySQL. Okay, just select this one, Control C and Control V. Automatically, it will create a copy. Okay. Okay, later we'll change the names. Okay. Now we need a input SQL query. Okay. Let me keep it here itself. Okay, this is for solution 2. Just observe here. So if you want, you can do drag and drop and you can configure, but I don't want to take so much time of you. Okay, that is the reason. See what we are doing here. Okay, see the previous query only. Just we are framing the query here. Select star from orders. Okay, select star from orders. Limit. See the same query we are forming. Okay, orders limit 10 and offset 2, whatever it is. Okay, dynamically we need to pass limit and offset values here. Okay, that is the reason. Just we took one variable. Okay, these are the warnings. Okay, don't worry about that warnings. Now, Snowflake, this is source system, right? So here the query it will take and it will fetch the values. And here we are going to insert. Here we are going to target system is MySQL. Okay. Now, so here what we are doing, we are using for each. We are using for each. Suppose you can consider you have 100 records. Okay. 100 records in the select query. So in order to process, suppose one record is going to take for 1 second. Okay, you can assume. Okay, 1 second. So how much time it will take? Okay, if it is 100 records, then 100 seconds. Correct? 100 seconds it will take. It's like synchronous way it is going to work. Okay, one by one. Now, I want to reduce the timing. Okay, I'll show you for both. Okay, how much time it is going to take for 1000 records or 2000 records. Okay, that we will see later, but try to understand what is for each and parallel for each here. Okay, if you use parallel for each, if we have 100 records, one record is going to execute for 1 second. So if all the records are going to run in a parallel mode, then how much time it will take? Only 1 second. Only 1 second. Correct? So which one is best now? If you compare to this one, if you compare to 1 and 2, which one is best? 2 is best because if you have 1000 records, how many seconds? 1000 seconds it will take. But here, so everything it will get executed in a 1 second. Okay. Parallelly it will get executed. Okay. Parallelly it will get executed. Okay. Let's try to see it in a practical way. Now, for each and parallel for each, right? So we do have parallel for each here. Just copy. So inside this, just place this query. That's it. Okay. Inside this, just we need to place this query. Suppose you want to see what is the query we have written. Okay, I'll keep on logger here. Logger SQL input. Input SQL. Hash symbol hash dot input SQL query. Okay, we are going to print SQL query here. Now, I want to keep on transform message saying like, okay, so the records are inserted. Records are inserted. Successfully using this is for our understanding purpose. Okay, using parallel for each. See, this one is solution 2. This one is solution 2. So solution 1 is, see, there are multiple solutions. Okay, I'll explain you one by one so that you can also practice in your system and you can able to correlate with, okay, which one is best. Which one is best. Now, let me run it. You know how this for each is going to work. Okay, anyway, in the previous video, we have discussed, okay, with the breakpoints. So here I'm not going to keep any breakpoints and I'll show you the difference. Okay, first I'll execute this one and how much time it is going to take, and I'll execute this one, how much time it is going to take. Okay, now go to Thunder client. Let me prepare the endpoint for this. Solution-2. Solution-1 and Solution-2. So what is the resource path here? Solution-2. Okay, fine. Now try to understand what is the limit and offset. Suppose if we have 10 records, if we are having 10 records, I want to process, okay, I want to process only first 3. How we are going to do? Okay, you can use top 3, but what about next 3 records? What about next 3 records? It's like there are 3 sets here, right? Okay, 1, 2, 3. So that is the reason we are using limit and offset. So this is called pagination concept. Okay. There are some website, okay, might be you have seen, okay, page number 1, 2, 3, 4, 5. See everything backend, it's an API. Suppose if the user click on 1, what will happen? What will happen? So there is a request will come from front end to back end. Okay. So here they are going to pass offset as 0. Suppose they want to limit as 20 records. Okay. So like this, suppose there is a second page. Offset. Okay. First 20 records we have to skip. Then the limit is 20. Something like this. They are going to pass. Okay. In the back end. We are going to fetch the results and we are displaying in a front end. So otherwise what will happen? Suppose it contains 10,000 records. It will take around 5 minutes. 5 minutes to execute. 5 minutes to execute your web page. So that is not a good idea. So this way we can increase the performance. This way we can increase the performance too. Okay, this we will talk about later. Okay. Now the limit. Suppose I want only, it will start from 3 and I need only next 7 records. So how we need to do is first 3 records we have to skip offset 3. Okay. Next limit is 5. So that means so every time it will fetch 5 records. The offset value will be 3 means okay, it will skip 3. So like this, what we are doing, suppose if we have 1000 records. So first time we'll process 100 records. Next time we can process 500. So that is up to you. Again, next time 500, something like this we can process. So that is the reason we are using pagination concept here, limit and offset. Okay. Now, what I will do, I'll remove the records from a target table. Okay. It's an empty now. It's an empty. So first I'll go with for each, how it is going to work. Offset is 0. Just observe here, offset is 0. So I want to process 1000 records. Okay, I want to process 1000 records. Just try to understand how much time it is going to take. So it is processing now. You can go here and you can verify the logs also. So inside the for each, so how many records? Okay, 260, 280, 300. It's like one by one. Okay, it's like in a sequential way, one by one it is processing. See here, one by one. Even you can verify here. How many records so far processed? 942 so far. See how much time it took? 40 seconds. Correct? 40 seconds. Make a note of this. Okay. By using solution 1 for 1000 records, solution 1 for 1000 records, it took, okay, below is the response, okay, 1000 records. I'll give it like this. Now, what is the solution 2? We are using parallel for each. So it will insert the records in a parallel mode, correct? Parallel mode. So the same thing, solution 1 offset is 0, okay? From 0, it has to start on the limit, okay? I'll delete these records. I'll delete it, okay, fine. Now we can see how many, 0, okay, cool. Now I'm going to send. How much time it is going to take, we'll see now. Okay, this is the query. This is the query we are using, but there is no loggers here. Okay, that is the reason it is not displaying. If you want, you can keep the loggers also. Okay. See how much time it took. So compared to previous one, is it less? So you may get a doubt. Okay, 1 minute. Just a second. Okay, this one, right? Okay, 200 is okay. Size is 58 bytes. Type is 24.40. Okay, let's verify. See, there are 1000 records. 1000 records we can see now. See, all this data, it is available. So compared to solution 1 and solution 2, okay, which one is best? So I can prefer solution 2. So compared to 1 and 2 only, I'm telling, okay, this one is good. Now, okay, 1000 records are done. Now you can skip the 1000 records. Okay, you can skip the 1000 records and you can process next 5000. So that means already 1000 is there. Now the limit you are going to keep it as 5000 here. 5000. Okay, I'm going to send the request. So now in the back end, see 1334, 1581, 1794. So it's like keep on. It's like keep on. It is going to insert the records into your target system. Your target system. So in this case, suppose if you go with solution 1, it will take a lot of time, right? Okay. So how much time it will take for 5000 records to process, we'll see now. And is this okay? So you think this one is the good approach? No. This one also had a good idea. Because what is happening, if you observe here, so every time you have to change offset and limit values. Every time you have to change offset and limit. Correct? Every time you have to change the upset and limit. Suppose if it is 50,000 records, if it is 50,000 records, yeah, at a single time we can give, okay, 50,000 here and you can run, but is there any failures in the middle? Okay, we are unable to handle, this. Okay, that is the reason we are going step by step. I mean, so like we are going some batches, So one batch we are considering as 5,000 records. Next batch we are going to consider as 5,000 records. Next 5,000, next 5,000, something will be like this. Okay. See, this will also work. Okay. If you have less records, or is there any manual intervention is required? Okay. So the user has to insert. Okay. He needs to decide. Okay. So I want to insert some records. So now he will skip 6,000 records. Okay. Because in our table, it contains already 6,000. See, 6,000. Okay. He want to skip first 6,000 and he want to execute next 500 records. Okay. In this case, this one is good. This one is good. Okay. See, for 5,000, how much time it took? 1 minute, 49 seconds. Suppose if we go with solution 1, hardly it will take 3 to 4 minutes. Hardly it will take 3 to 4 minutes. Okay. So that is the reason. Now we have opted to solution 2. We can use parallel for each. Inside this, you can keep insert. Okay. Inside this, you can keep foreach. Okay. Now the user want to place, or he want to insert, he or she, he want to skip 6,000 next 500 records. Okay. Let's see. For 500, hardly it will take, I think, 15 seconds. We'll see now how much time it is going to take. See, 11 seconds. Okay. 11.21 seconds. Yeah, that's it for solution 2. The solution 3, I'm going to explain in another session. Okay. That's it for this video. Thanks for watching this. Happy learning. Practice. Be practice. Okay. Let's try to practice. Then only you will learn the things. Okay. Thank you.